Hello sir, we are students of Sanjay Gaurav group of institutions of computer science department and we are going to explain our final year project on lexicon based sentiment analysis. Our group members are Prathamesh Dhanavde, Kedar Jadhav, Pratik Londe, Mangesh Phule and Shubham Jagdale. And our project guide A.S. Kamle sir. Now we are going to introduce our project. So, as we seen all around us in today's technological world, many of our population using social media. So, in recent times, people are using social media and networking sites for expressing their sentiments, views, opinions, etc. And the opinions of other peoples have always been important to us in many ways. Over 1.5 billion registered accounts are there on social media, and billions of images and videos, posts, and messages sent through social media sites. So, social media is responsible for generating a large volume of data. Sentiment analysis renders to the understandable information connected to the people views as it examines diverse reviews and tweets. It is a verified effectual tool for prediction of numerous imperative events like general election and also box office movies. Now I give an example of sentiment analysis. Suppose a Amazon product is there. So whatever the product is sell or buy by the customer, so that review of that product is given by the customer in their review box. So that feedback, that review is analysis by the businessman for their product growth. So it is an important to analysis the sentiments of people to grown up in today's competitive world. So sentiment analysis is important for each and every business. Now we move forward towards our proposed system. In our proposed system, we are using a lexicon based approach. This is a technique guided by the utilization of a dictionary comparison of pre-tagged lexicons. The input text is transmitted to the tokens by utilizing the tokenizer. All newly arriving tokens are then matched for the lexicons in a dictionary. If a positive match is encountered, then the score gets added to the total pool of a score for the inputted text. The proposed system of sentiment analysis in the social web framework for sentiments is classified as following. First is a text mining, then text cleaning, then lexicon module, and then our sentiment scoring.
Hello, our project is lexicon based sentiment analysis, and there are different types of sentiment analysis using different strategies and techniques. So we have used a lexicon based approach in which we are going to use corpus based sentiment analysis. So what is a corpus? I will tell you later about it. So let's get started. I will show you how we fetch the data, Twitter data, which is raw and live using Twitter API called TweetPy. For this, you have to apply for Twitter developer account, and here's the code for Twitter streaming data. So here there are code for Twitter streaming data. There are libraries which we included like TP streaming, import stream listener, authentication handler, and stream for streaming the data. There are 4 keys, which is consumer keys, consumer secret, access token, and access secret. So we got that from Twitter developer account, which is TweetPy API. So here is my dashboard for developer portal, and this is my project sentiment analysis. Here you can check the how we gather data, collected data, and this is my app. This is a setting of for the lexicon based sentiment analysis, and the keys for that we are going to use in our project. That is a consumer key, consumer secret key, access secret key, and access token key. This we have found it here. This is a API key and API key secret. So we need access secret token and access key. So you have to generate it twice. So we have already generated. I'm not going to generate it. This is a function on data for streaming Twitter data. we are going to save in CSV file, that is filter.csv, and we're going to use data id created item text. This is column of data, my data. This is the main function. We are going to first listen on the port, that is set. We have set the listener, and later I'm going to authenticate, and this is a filter we are going to use, like India movies Flipkart. I will fetch that same data into these filters. So here is the I'm going to run this. So python tstream.py, and this is set listener update, and here I can fetch this tweet streaming, and these are all the tweets I'm collecting from Twitter itself. So I will have this data right here. I'll show you. This is going to this folder in filters. This is our tweet data. It's in a raw format, so it will show as in a raw format, which we can't understand it. Later I will show you the how we calculated the further part, like calculating polarity of tweets in stream. So here is the code in SentimentAnalysis, which we implemented in Jupyter Notebook. So I'm going to open Jupyter Notebook. Here's the code, and this is our file for based sentiment analysis. Here we have done all the data pre-processing and polarity calculations. So it is the libraries, which is import re, import nldk, string, warnings, numpy, pandas, keyboard, matplotlib. Re4 is used for regular explanation, nldk for text manipulation, string for string functions, warnings for generating warnings, numpy for computing numerical values, and pandas for database, keyboard, matplotlib for the graphical representation. So I have run the first part, libraries. It will take time to import the libraries. It's running because of this US star. After that, we reading the filter.csv, which we fetched from Twitter streaming data. So we have got that data. This is there are two labels, 0 and 1, for our tweets. So I'm checking whether values regarding label 0 and regarding label 2. This got, and the label which is and this is the count of the label 1. So first, after that, we need removing the patterns, noisy data from our tweets, like add hashtag. So we need this function remove pattern, in which we collect input text and pattern. Here is in function we have input text and pattern, and for the regular expression find all the patterns to replace with the input text. This is, we are going to remove the apostrophes. This is a vectorizing our data. This is like removing pattern, which is consists of add, and we have removed the add symbols, and we collecting the noiseless data, which will helpful for accuracy. And here is the we have removed the regular expression, as well as a string will replace the hashtags. Like here is add Twitter handles, it will remove into this in this. So this is the we are going to apply lambda function, because whenever there is a length of words of length is less than 3, it will not show sentiments. So I'm going to eliminate this short length words. So after removing, I got this tidy tweet as crying calls. After this, really move deep down, which makes sense to calculate the sentiment of this analysis. So here is a tokenized tweets. What is tokenizing? Is the computing tokens of the words. Like for this was a sentence as crying call softy. This sentence is like this was a crying call softy. This really moved deep down sentence. So after tokenizing, I will have crying call softy. This is separated tokenized words. So here is code for tokenizing tweets. We got that crying calls update, and this is border streamer method function. What is a streamer actually? Streamer is the generating root word for the our words. Like there is something like interesting. The word will be interest. This is we are generating the reviews reviews review.csv, which will consist of only the tweet IDs and tweet sentiments. So we computed it in CSV file, the read.csv. I'll show you read.csv file here, and this is read.csv. There will be IDs and tweets only. This is the whole tweets till we calculated we computed from this data preprocessing functions. This is text block for polarity calculation of each sentences. This text block library for Python, and we read the read.csv file here, and this is the function for polarity calculation, and we set the axis 1 because we want to calculate polarity of sentences. Here we got a polarity of the all the sentences. This is a crying call subjects. It have polarity minus, which is negative. There is some positive 0.061, so it's a positive 1. Is all the polarity calculated of the all the sentences. So we need this data, so we convert it into XLS format. I'll show you the output file, which is in XLSX form. We can't see in sorry, it is not encoded. I will show you in XLS file by opening XLS file. Here is our data. So there are reviews, polarity, and scores. Reviews are tweets, polarity is which is actual polarity, and scores there is 0 and 1. There is positive sentiments and negative sentiments. So that's it. So we read the output file here, and I'm showing the output. Here is the the file is open, so we can't read from that file, convert to that file. First I need to close this file. Yeah, closing this file, and after I'm going to run it. Yeah, it works. Yeah, it's saved into output.xls. I read the X file, and I got all the polarities and score. So the data file created here is the output file. This sentiment score. We have calculated the polarity of each sentences. We need to words, so we need to calculate the sentiment score of each sentences. So here is the code. We have tweet data list defined tweet data xyk starting first function. We used open the tweet data. These are the functions which will run all function. First it will run get data. This is a file filters or takes you to gather data. First after the Twitter pre-processing. So get data, there is a function. We retrieve this text file. We open that file. We load it into the JSON format, taking line by line and appending to the list. And after that, it will redirect function, which is adding the dictionary to call. It is like a testing our dataset with our dictionary, and this is a TSV file, which is dictionary, which is handpicked and which have a polarity of the words. It has a I will show you this dictionary file. It is of 5,000 words. It's limited and handpicked, so it's not that much accurate, but still We are doing this to calculate sentiment analysis. We can increase efficiency by adding the more words, and this add polarity function. So what is add polarity function? Here it is add polarity function. We have started the time with taking these tweets and calculating each word's sentiments, which is positive, negative, or neutral. So where some word is the word's polarity, so we need to calculate this polarity of each sentences. So here if some word not equal to 0 1 0, this is a function. The formula sum more is equal to sum num divided by some word. Here we going to find the polarity of the sentences. Like if there is a word sentence, then calculate each polarity will be calculated plus divided by number of words which shown the sentiment. So we are going to save these files, sentiments and tweets headers as id in sentiment in output1.xls. Here's the file which is new, where we got IDs and sentiments of each tweet, like 0 1 -1, this positive, negative, or neutral. So the first part is done, data processing. So we need to process the trend and check the accuracy of our result. So here's the accuracy checker. This code for checking out that our model is how accurate. This tweet data list, these are list tweet data x and y, vectorized count, vectorizer. We have seen the vectorizer function, like it converts the sentence into the words, and this stop words in English are like the, a, and the short words. And this is the function for the return tweet, which is which we processed for first, like it is like 10 data set. So it will add into tweet data. This retrieve process data. We're going to read Excel file, which is output1.xl. There is a sentiments and ID. In tweets data, there is filters file which will calculate the ID, and after that sentiment of ID, which will we will compare it, and we will convert into x and y. This x for the tweets ID and y for the sentiment of that ID. So plot confusion matrix, it is a function for showing the graphical representation of how our data shows the actual and predicted values. So this is the parameters of confusion matrix. This is the code for graphical representation, like colors, x ticks and y ticks for the labeling, annotations, and y label is for true label and x label is for predictable. Whenever I will run confusion matrix, I will show you. So now actually we're gonna run the algorithms, which is n-bit naive bias and all the others. First we will check naive bias. So what is a naive bias? Naive bias is a classifier and model that assigns class labels to problem instance represented as vectors of feature values. Like assumption of independence among predictors. There are different features which can independently shows that it is the predicted value. So here's I'm gonna explain the code here. This is a fit trend features int r for y. This is the tweets. We are training the tweets values, and we convert it into. This is a prediction function which will test against our raw data. There is a FPR for false positive, true positive, and it will show the neighbors accuracy and how it will completion speed. After that, we go into decision tree algorithm. So what is decision tree algorithm? So it is basically a graphical representation of all the possible solution to a decision based on a certain condition. There are various decision we made it, and this is same like in a buyer's code. Like here we actual data is in a y level, it's also in a prediction level. Prediction is same we are going to calculate the predictions. It will check the accuracy of the decision tree. And for SVM is support vector machines. Support vector machine learning algorithm that is useful for classification. Actually, it is based on idea of finding the hyperplane that is best divides the dataset into two classes. The code remains the same, which is from scikit library, so the accuracy part relation same. After that, we have checked against the KNN, which is nearest neighbor algorithm, which is very famously known because of the shortest. It's easy and efficient. So this is the function. This is same for all the algorithms, but there is neighbors is 2. So we are calculating the nearest length of 2 only. So we calculate the KNN accuracy and completion speed, and finally it's a random forest algorithm, which is a bunch of decision trees. It using bagging feature and randomness when building each individual tree. It is very efficiently for large data set, and accuracy also is efficient, but the cons is it overfits for noisy data and difficult to interpret. Max depth 2 is the length of the tree nodes from root nodes, like leaf nodes and root nodes. So this is a runoff function. We are going to process all the function. First data, process data, in bit and data in D-tray, SVM, KNN, and all these algorithms. So I will run all the functions here. I'm going to run accuracy file. Here we will have a result, all the details about how accuracy and completion speed. Now as we got 93.83 their speed, decision to accuracy we got 98.57, completion of 5.9, support vector machine, this which gives 50% accuracy, which is not efficient, KNN 81 and random 56. Support vector machine does not work because it's for smaller data, not larger data, and noiseless. It's not less effective on noiseless data, and actually we gathered all the noisy data, live data, so it will not efficient for our model. So here is the differential sentiment analysis file where we store all the code, where we we categorized all the functions here. There is all the function which is the same in accuracy checker file. Here I'm gonna show you the float confusion matrix, how confusion matrix shows the n-bit trend function. N-bit trend is for neighbors, and data tree. Actually neighbors have all features independent, so it will works well with high dimension data. And decision tree is perfect for visual interpretation and easy to explain. Random versus decision sort of a decision tree algorithm. Here's the runoff function. I will run all the codes, and this is the data. We are going to use decision tree. Actually it gives the efficient output and correct accuracy also. So this is imported from SQL library tree. This is the same code for the algorithm decision tree. So we are checking against live tweets. We are going to input. So if there is output prediction value is 1, it's positive. If there is 0, this is neutral. and the prediction is minus 1, then it will be negative. And if there is not there is nothing, it will nothing. It will I'm going to run all functions. Input tweet for inputting our tweet from console. So I'm gonna run this file. I run this file declaration.python.declaration SentimentAnalysis.py. Here he will have all the neighbors. Here's a confusion matrix or neighbors classifier. This is a y label for true label, x label for predicted values, and all the values are -1, -1. This is for true label and predicted label. I will tell you later about how this value is calculated. There's next algorithm, decision tree algorithm. The confusion matrix for decision tree algorithm. This is same for true label and prediction label. The same I will interpret later. After that, it is now is SVM support vector machine. The accuracy of decision tree is 98.57, which is very efficient. This is for SVM classifier, support vector machine classifier. It will not effective for our dataset because it giving the neutral output for all tweets. So we are not going to use that as a support vector machine algorithm actually. After that, which will have KNN sniper. It gives the 81%, which is very also efficient, but not as a decision tree algorithm. This is random forest classifier. Random forest, it is a collection of decision tree. Our data is 2 dimensional, so we are going to use decision tree, not a random forest. Random forest is efficient for multiple tasks. So here is the input. I'm inputting my tweet. So it is font and easy to do sentiment analysis. This is tweet. It will show, what is it show? Positive, yeah. I'm going to check against the live data. I'm going to copy the live tweet. So here I'm going to copy this tweet and paste in. What we'll have is negative, and this is the another one. We'll check what will be the output. Yeah, happy Sunday, new weeks in advance. It will be positive. It should be positive. Yeah, it's positive. Yeah, thank you.